All right, so this is CS50, and this is lecture 2, our continuation of C. And for the next several weeks, we're going to keep using C, but we're going to focus less on the language and the syntax, which we'll get experience with over time by way of the problem sets, and more on the ideas and more on the problems that we can solve. But before we forge ahead with anything new, let's take a quick look back at where we left off and what we'll sort of assume for today's comfort level and ask any and all questions along the way. So in order to program last time, we needed a tool. And that tool was this thing here, CS50 IDE. If you haven't dived in already, you probably will this weekend for problem set 1. And this will be a web-based programming environment that's got all the requisite tools you need in order to write code, compile code, and then starting today, debug code or find mistakes in code. But this is requisite because it's not sufficient to just write this. What do we call this, generally speaking? Yeah, so this is source code. So this is code. When someone says, I write code, they write stuff like this. And this is particularly a language called C. But of course, computers don't speak C, and they don't speak Java, and they don't speak Python or C++ or any of the languages with which you're familiar. They only understand what at the end of the day? Yeah, so binary. So binary is, of course, zeros and ones, otherwise known as machine code in this context, insofar as it is code. It's instructions that implements some problem-solving techniques, but it's just zeros and ones that computers understand. So we needed a tool to get from A to B, and that was called what? Yeah, a compiler. So a compiler, of course, does this for us. Source code is the input. Compiler is the program, or really the algorithm, albeit in the form of a piece of software. And then the output is machine code, zeros and ones. And for our purposes, we're not going to worry about how we get from step A to B per se. We'll want to use the tool. But this is another area unto itself in computer science if you want to understand how compilers work and how humans got from literally zeros and ones to something called assembly code to higher level languages. You'll see a glimpse of that in CS50. But it unto itself is a whole field that might prove ultimately of interest. But this, more mechanically, is how we compiled code. Clang is a compiler, stands for C language, and it's just software that some humans wrote some years ago. And there are alternatives. If you've ever used Visual Studio in the Windows world or GCC in the Linux and Unix world, there's bunches of other compilers. We just happen to use Clang, since it's pretty popular. And then that second command is even stranger looking, but it represents the act of doing what? ./a.out. Yes, over here. Yeah, running the program, exactly. So ./a.out is a cryptic way of running a program, but it's like the textual equivalent of double-clicking an icon. And a.out is just like the default name you get, assembly output or assembler output, when you compile a program without specifying its name. But we were able to specify a name. If you introduce a technique called command line arguments, you can be a little more precise, clang-o for output, then any word you want. In this case, I went with hello, and then the name of the program or the file that you want to compile. But this, of course, gets pretty tedious. And in fact, there's a missing step. Sometimes when you want to write a program, it suffices to compile it exactly as that. But let me go ahead and do this. Let me go ahead into CS50 IDE, and let me go ahead and briefly do the following. File new, and let me go ahead and save this as hello.c. And just for memory, I'll quickly recreate that same program, int main void, and then we had printf, hello, comma, world, and then just for good measure, \n, which means move the cursor to the next line. And now I'm going to go ahead and save that. If I go ahead now and run clang hello.c, looks good, and ./a.out, that looks good too. But recall that we introduced some other functions the other day as well, like getString and getInt, and we'll see bunches more before long. And if I do that, notice that I have to do a couple of things. So if I want to do like string name getString, and then quote unquote name to prompt the user, recall that the left-hand side says, hey computer, give me a variable that's going to store a string, call it name. Could have called it anything. I could have called it s. But why might it be arguably better to call my variable name instead of string, or s rather? Yeah. Yeah, it's just clearer, right? It might be a very marginal, nitpicky detail, but it's just clear. And when our programs get bigger, it's just nicer to be able to read words and understand implicitly what they mean without having to think through what x or y or s or whatever it actually is. On the right-hand side, meanwhile, we had this function getString, whose purpose in life is to go get a string from the user from his or her keyboard, prompting them with a word like name, and then return it, just as Sam handed me back a slip of paper with a name on it. But there's a catch. It's now no longer sufficient to just adapt my code for this new approach. And I had, again, to change that second line, I had to give a placeholder which is %s. And if that's a little cryptic looking, just kind of think of it like a Mad Lib, if you're familiar with those, where there's just like a fill in the blank here. And all %s is doing is saying, put a word there. What word? Well, whatever comes after the comma, whatever variable or value is there. So that's good, but a couple of things can go wrong. And let me point those out so that you don't perhaps trip over it yourself on your own. Let me go ahead and do clang hello.c now that I've made these changes and saved them. Bunches of errors all of a sudden, even though I've not changed all that much code. Again, rule of thumb from last time should be, even if there's lots of error messages, always look at the first one first, because the rest might just be kind of a resulting cascade of errors, only one of which is important, which is the first. Now it says use of undeclared identifier string. Did you mean standard in, which is something else altogether? I didn't. I meant string. And it turns out that string is a feature of the so-called CS50 library. So this is one of these training wheels we're just going to use for a few weeks until we dive in underneath the hood of strings too. But in order to use anything from CS50, what did I need to add to my code too? Source code, yes, but what else? The library. And the library was the CS50 library, and that means there's a file somewhere on the computer in the IDE called cs50.h, so-called header file. More on those in a bit. And so I did forget that detail. But suppose you don't recall that yourselves. Well, you might recall from one of our orientation sessions that CS50 has tools with which to help for this too. You don't have to turn to this course's online discussion forum. You don't have to go to office hours necessarily for error messages like this. If you can't quite wrap your mind around what's happening, go ahead and do this instead. Instead of just running clang hello.c, do something like help50 clang hello.c, where help50 is a CS50 specific command, sort of a virtual teaching fellow, if you will. And if we recognize your error messages in yellow at the bottom, we'll highlight the first one, and then we'll try to give you advice like you might get in person. So by undeclared identifier, clang means that you've used a name, string, on line 5 of hello.c, which hasn't been defined. Did you forget to include cs50.h, in which string is defined atop your file? So we'll generally try to prompt you with rhetorical questions that hopefully are correct in leading you toward the right solution. So OK, that jogged my memory at least, even if I'm not yet 100% comfortable with what these lines really are doing. And we'll tease that apart more today. But it feels like I'm trying to do this. But it turns out there's one other gotcha here. Clang hello.c, enter. Dang it. Well, actually, this is a net positive, right? Fewer error messages, it would seem, but now one we did not see the other day. Undefined reference to get string. So it's kind of similar in spirit, like something is not understood, but it's different wording certainly, and I'm not quite sure what that means. But it turns out that it's not sufficient just when using most libraries to use include cs50.h or other header files, as we'll eventually see. That just teaches the compiler that something exists. It was like briefly last time when we talked about prototypes, where I put a little one-liner that just said, by the way, this function's eventually going to exist. That's what the header file is doing. It's like a promise to Clang, this shall exist. But there's a second step. You actually have to feed Clang the zeros and ones that implement the CS50 library that you, of course, did not create yourself, but we did pre-install in the IDE. And there's a separate way of doing that. Rather than just do clang hello.c, you have to do what's called linking your code against that library, at least if it's a third-party library that doesn't come with the computer. It came from humans like us. So this now says, hey, Clang, compile hello.c, but link it against the CS50 library, which means take my zeros and ones, take CS50's zeros and ones, combine them, and then give me my actual program to run. And so that's going to be a key ingredient, and help50 could guide you toward that solution. But if I hit enter now it seems to compile /a.out, my name shall be David, enter, and it says hello, David. So again, don't get hung up ultimately in office hours and problem sets on these kinds of errors. You're going to hit these bumps from the get-go, but just realize, look for sort of familiar words, use things like help50, reach out to the course online, and just get over those hurdles. Because at the end of the day, the interesting stuff's going to be the logic of the programs and the actual problems we're trying to solve. So what is it that's actually then going on here underneath the hood? And frankly, this is very quickly becoming tedious. So how do I automate some of these processes? Because it's very easy to forget this, and it's just very boring to continue to type so many commands. Well, recall that there was a shortcut we talked about the other day, which just kind of hides all of these details. You don't need to remember -o. You now don't need to remember -l CS50. What do you do instead to make a program? Yeah. Yeah, so make, it's not a compiler itself. It's just kind of a helper program that knows how to run a compiler for you. So frankly, the simpler approach is just to do that, make hello. And the reason it outputs so many more words is just because we have, in anticipation of teaching the semester, sort of pre-configured it with command line arguments, additional words, that we expect you're going to need at some point. And this just saves you the trouble of having to futz around with a manual to figure that kind of thing out. But that's why it looks cryptic. But notice, this is really the most important word, hello, followed by hello.c. And those are your two ingredients. All right, so what's going on then underneath the hood there? Well, it turns out that even though we can simplify the command structure, it's actually doing quite a bit for us. And this is the process of compiling, but that was kind of an oversimplification, or put more intelligently, like an abstraction. There's actually quite a few steps that go on underneath the hood, one of which is called pre-processing and compiling and assembling and linking. So let's do a quick dive down here, but then we'll abstract away just so that you've seen what's going on. But henceforth, we can just take for granted that all of this is happening. So here is source code, same program as the simplest version we had a moment ago. And ultimately, I need to get this to machine code. Well, let's see if we can't just visualize how we get from point A to B without completely abstracting it away with just those big arrows. So this is my source code. And it turns out that the very first step of turning source code into machine code in the world of C is you first run what's called a preprocessor. You don't do this explicitly, although you could if you were really low level and interested in it. But what the preprocessor does essentially is anytime there's a line of code that starts with a pound sign or a hashtag these days, that's what's a special command that gets essentially replaced with the contents of the file, at least in this case. So somewhere on the IDE is a file called literally standardIO.h. And so hashtag include means go get that file and essentially copy and paste it here. And so when you pre-process your code, this yellow line here becomes something like this. And I'm doing ... because it's dozens, if not hundreds of lines long. But there's one juicy line in it, which is the little clue to Clang that printf shall exist. And that's why you need standardIO.h. So that's essentially, for our purposes today, all the preprocessor does. It does these kind of find and replace style operations so that now your file, without you knowing it, suddenly became much bigger because it's got other lines of code that someone else wrote. And then your code remains right there as it was. But the next step, after pre-processing, is something called compiling itself, which technically the compiler, if we really want to be nitpicky and look at its formal definition, is actually taking these yellow lines, your source code and someone else's perhaps, and converting it into something called assembly code. And this is a language that humans kind of sort of still do, but back in the day really did program in. And in fact, if you have a computer with an Intel CPU, a brain made by Intel, inside of your computer, there was and still is, a big user's manual that tells programmers around the world that this Intel CPU understands the following instructions: add, subtract, multiply, divide, all the basics. And then things like move numbers from here to here, read numbers from here to here, just move stuff around in the computer's memory. And so even though this really looks cryptic, even to me, since I am by no means an expert at assembly language, certainly all these years later, you can see words that kind of sound familiar, like MOV suggests moving a value from one location to another. Sub alludes to subtraction, so subtracting one number from another. And without really thinking this through carefully, I'm not really sure what's going on yet, but I do see a familiar word down there, call printf. And so long story short, what the computer, or compiler specifically, has done is it's taken my more user-friendly C code, converted it to something that's a little closer to what the machine understands. But it's not there yet, because the machine only understands zeros and ones, so there's another step called assembling. And the assembling process simply takes assembly code and converts it to zeros and ones. Now we're down to the zeros and ones. And what's amazing, if it's interesting in the first place, is when you run Clang and hit enter, all of this is just happening instantly. And you're getting these zeros and ones as output. But I've left room on the other side because all we've done is convert my code from source code to assembly code to machine code. What needs to now be merged in, so to speak, for that hello world program? Yeah, so we still need like standard IO, the standard IO library that has printf. So the next step is to take a whole bunch of zeros and ones from somewhere else on the system, combine them until this is the file containing a.out or hello, whatever you called your program, and that ultimately is what the computer understands. So that is a very low-level detail. Thankfully, we learned in the very first lecture this notion of abstraction, which means even as you dive in underneath the hood and sort of understand how we're building up, now, henceforth, literally every minute hereafter, that whole mouthful just becomes compiling. And indeed, that's what most people in the programming business refer to as compiling, is all of those several steps. But that's all that's happening. Feels like magic, but it's just one step after another gets us closer to our goal. Whew. Questions? It's about as low level as we'll get. Yeah?
Why do you have to go through assembly code and then the machine code? Why not just go straight to machine code?
Good question. Why do you have to go from one step to another, like from a source code to assembly code to machine code? You absolutely could. It just happens to be the case that there's lots of humans in the world and lots of people working on different projects. And this notion of layering your software on top of someone else's, on top of others, allows us to build more complex systems much more cleanly, if you will. And there's different types of computers in the world. There's Macs, there's PCs, which even though these days they're a lot more similar underneath the hood, literally, than they used to be back in the day, there's different CPUs. There's phones that have very different CPUs. And wouldn't it be nice if I could write my programs in one language and compile them into zeros and ones that do work on a Mac and on a PC and on an Android phone and an iPhone and so forth. And that's why by having these sort of different layers, one set of humans or one person can implement the process of converting C to assembly code. Then someone else can take it to the zeros and ones in some sense. Or there's even intermediate steps. Compilers have front ends and back ends and all of this complexity. But it gives us advantages because it means we can sort of decide which types of hardware to support more easily. Really good question. Other questions? OK, so with that said, let's now consider any number of ways in which things can go wrong. It's easy for me, certainly, to write hello world, and everything just kind of works. And even when it doesn't, I quickly know how to fix it. And it's only from experience and practice. But let me just give you a teaser, not just of Help 50, but two other tools that you'll see, particularly for the problem sets, that will not necessarily teach you how to write good code, good efficient code. That's where the humans come in and the teaching fellows feedback and sections and office hours and more. But at least to write correct code that meets our specifications and that's well styled. It at least looks good. But the third ingredient, recall, besides correctness and design, correctness and style, is going to be design, which is something we'll learn after practice and examples. So with Check 50, this is a tool that comes in CS50 IDE, recall if unfamiliar, that allows me to essentially do this. Let me whittle this back down to my simplest hello world program like this. I no longer need the CS50 library. I can run make hello. Seems to work. And how do you go about testing your programs if you've written this for a problem set? Well, the easiest and most straightforward way, of course, is just run it. Looks like it's correct. And it is. And there's not too much that can go wrong in this program. But soon you'll see with problem set 1 and beyond, anytime you start getting input from the user, where he or she has to type their name or a number or other things, you can absolutely concoct scenarios where something goes wrong. But if you run a command in this case, like check 50, we can do the following. Let me go ahead and first make a directory called let me go ahead and do this and do make dir for make directory hello. And then we didn't see this the other day, and you'll see more of this in today's super sections or class-wide sections, which will also be filmed. I'm just going to move this file into a directory called hello. So that's like on a Mac or PC, just dragging and dropping it. But I'm doing it with my keyboard. What's the command to change into another directory? CD. So that's like double-clicking on a directory, albeit with my keystrokes only. And now I'm going to go ahead and run this. I can run make hello again. Seems to work. And I can run /hello. Seems to work. But now let's see if CS50 agrees. So check 50. And then I'm going to type CS50 2017 fall hello, which looks like a bunch of folders, but it's not. It's just a unique identifier that has sort of some hierarchy to it. You would only know to type this by reading a problem set specification online. And what this is going to do, if you haven't seen it already, is actually connect to CS50 server. It's going to authenticate you if you haven't already. I'm going to go ahead and log in as student 50. And now, hereafter, it will remember my password for at least some amount of time, so you don't have to type it in every darn time. Then it's preparing, it's uploading. And what's happening now is my hello.c file is somewhere in the cloud on CS50 servers. We are running the checks, the tests that the staff wrote. And hopefully, I'm going to see a whole bunch of green, smiley faces. that look a little yellow on this projector, but those are in fact green smiley faces instead of frowny faces, which would suggest something is wrong. So that's all good. And don't be discouraged if you see a few frowny faces or a few flat, confused faces if something else is awry. But style 50 does something different. Right now, the style of my code, I'd argue, looks pretty good, because it's kind of hard to go wrong when it's this short, but we'll see a way. And if I instead run style50 hello.c, just the name of the file I want to check, looks good, but consider adding more comments. And that's pretty compelling because there's 0 at the moment. And so what kind of comments might you want to add? Well, in this program, it's not that, that compelling to add that many comments, because the reality is this program is so short, it's probably takes me less time to read the code than the comments. But it's very common, as you'll see in the examples from lecture, to do something like that, like this. Says hello to user. Just a quick one-line summary so that when you're skimming the file or looking at the code, OK, I got it. I know what this does. And if I care to know how it does that, then I can read the code. And so that would be a comment, and that will probably make style 50 helpful in this happy in this case. But what if I'm getting a little sloppy and I remember vaguely that I was in the habit of hitting tab or the space bar in lecture, but I can't be bothered to do that when I'm working on my problem set. I just want to get the darn thing to work. It's not uncommon for code to eventually start to look like this, even though this too is a simple program. Now, good style, as you'll see and learn from practice, dictates that just like in Scratch, there were those yellow puzzle pieces that kind of hug the code. Similarly, inside of curly braces, you really should be indenting. And so if I go ahead and sort of forget that and now run style50 on hello.c, I'll see my code outputted in the terminal window, the bottom of the screen, but green suggests, hey, programmer, add the following characters. So green suggests add here, and if I go ahead now and re-indent that by hitting tab, specifically 4 spaces, which is a human convention, it should make it happy again. We can go in the reverse direction, though. Suppose that I got a little confused as to what I actually am supposed to indent. And you might even see in textbooks and some online resources, some people write their code like this. Let me go ahead now and run style50 on this. It's going to print out my code in red. In this case means remove those characters that you might not otherwise see. So it's not always going to be perfect, and especially when the programs get long, might be a little non-obvious what changes you have to make. But just like with error messages, start at the top, make one or few changes, save it, and rerun it, and see what the updated advice is. And I can't stress this enough, especially with problem set 1 and any problem set thereafter. Don't get into the habit of sitting down and trying to bite off the entirety of a problem. Odds are with Scratch, you didn't sit down and write the whole thing without once playing it or testing it or adding features to it. Don't get into that habit then in C. Take steps and steps, just as we've been doing with these examples so far. All right. Any questions then on those tools? And we'll come back in just a moment to more sophisticated debugging techniques. All right. So one of the problems that, as we were distracted by earlier, is there's this old school game, Super Mario Brothers, wherein a character like this jumps around the screen quite a bit, and it's one from the very first Nintendo game, and there's lots of obstacles in the way of Mario as he's running left and right and jumping. And some of these obstacles can be represented with fairly simple constructs like bricks in this colorful world, and we can approximate this just by using characters on our screens as well. So I actually poked around for far too much time last night looking at old Super Mario Brothers maps, which if I had them in like the 1980s would have made Super Mario Brothers a lot easier. But people have captured all of the imagery from this game, and one snapshot from this game was a screen like this. So eventually Mario's supposed to run through this, and he's supposed to bump his head up against the question marks and get coins and so forth. But for now, I'm going to really, really simplify this and propose that all I care about for the sake of discussion is this line of question marks. How would a computer program, whether in Super Mario Brothers or today here in Sanders, go about printing like a line of question marks in a row like that? Well, let me go ahead and open up CS50 IDE. I'm going to go ahead and create a new file here. And I'm just going to go ahead and call this, say, Mario0.c, because it's the first or 0 version of this program. And I just want to print like 4 question marks. So let me take a stab at this first. So include standardIO.h, which I think I need because why? Yeah, I need printf. I need to be able to print the character. So int main void is what comes next, and we'll start to tease apart why that is today. And now I'm going to go ahead and print out question mark, question mark, question mark, question mark, and then semicolon. All right, let me go ahead now and make Mario 0 /Mario 0, and I kind of sort of have a very ugly textual representation of a really fun, at least 1980 style game. But there's a slight aesthetic bug, and I made the same mistake the other day. How do I move my cursor onto the next line? Yeah, so \n. So backslash is the one we're about to type, and / or slash is what people would call just the other direction. So that's \n, and that's a special escape character, so to speak. Right? It's for now, just know that this starts to confuse the computer if you just like literally hit enter. Like now your code's on 2 lines when really it's just one idea or one function. So humans decided some time ago, let's just represent that special character that you would otherwise just hit on a keyboard. So now if I rerun make Mario 0 /Mario 0, OK, now it looks a little better. But we know from scratch that we don't just need to do question mark, question mark, question mark, question mark, especially if I want even more coins to be available on the screen. What's the right programming construct to just give me more of these? Yeah, like a for loop, right? So let me go ahead and tweak this a little bit. Let me go ahead and in, let's say, Mario 1.c, so Mario 1.c, I'm going to instead do this. So for int to give me an integer, I, equals 0 by default, though it could be 1, but programmers tend to use 0. I is less than, I'm not sure, so let's just put a big blank there for a moment. And then I++, I remember, being the way to increment. And then inside of this loop, I'm going to do printf, question mark, semicolon. And now let's answer this question. If this for loop, which recall has a very methodical process to it, it initializes, checks the condition, does something, increments, checks the condition, repeat again and again. What number should I put on the otherwise blank line here? So 4. But if I'm counting from 0 to 4, that feels like it's 5 numbers. So 3 might get me closer, but less than. We have this relational operator. Less than could have been greater than in other contexts. So the less than actually saves us. If I do 4 here, think about logically what's happening. I gets initialized to 0 for the first time, and we get a question mark printed. Then it gets ++, and so it becomes 1, which is less than 4. And so that's the first time I printed a question mark. Then I becomes 1 next. I print another one. I is now 1. I do another. I is now 2. I do another. I is now 3, which is not consistent with the number of fingers I'm holding up because I started at 0. But once I becomes 3, and therefore I've already printed my 4 question marks, the next value I is going to take on is 4 itself. Is 4 less than 4? No, so I never get a chance to print another question mark or put up another finger. And honestly, this is like a waste of intellectual capacity to like think through, OK, how many numbers are between like 0 and 4? We could have, like most of us in this room just think, could have just done I is less than or equal to 4, and that too would have worked. This is even more clear, perhaps. You start at 1, and you count up to and through the number 4, and that will give me 4 fingers as well. Why do we start counting at 0? It's kind of just because, but more technically, it's because it's easy to start counting with all 0 bits per our first lecture. So it's just a habit. And it's fine if you're more comfortable this way, but before long, get into this habit just because everyone else does it this way. OK, so now let's go ahead and print this out. Make Mario 1 /Mario 1. Still that bug. OK, is this going to fix this? Why not? Yeah, that's going to do question mark, new line, question mark, new line. That's not right. So what line number should the \n really go on or between? OK, so it should go outside the for loop. So specifically, I saw a hand in back too. What line number? Yeah. Yeah, so like between 8 and 9. There's no room there at the moment. That's no big deal. We'll just hit enter, printf, and I can certainly just do a single \n even with no words to the left of it. That too is OK. Let me recompile this. And honestly, if you get bored retyping the same commands, know that you can also hit up and down on your keyboard, and it will go through your history, so to speak. And that too, over time, will start to save you time. So there's make Mario 1, enter, /Mario 1. Or I could just scroll back up as I did before, and now I get those 4 question marks. But now let's actually create this a little more interestingly as follows. Let me go ahead and not just hard code 4 into this program. Let me make one more version of Mario, call it Mario 2.c, and this time actually get some user input. How about I do int n, because n is like a number, and it's just common convention to call it that. Get int, and then I can say number, semicolon. And now instead of hard coding 4, why don't I just put n there, which I can certainly do. So let me go ahead now and run make Mario 2. Uh-oh. Error. Yeah, I forgot CS50.h. So I have to go back up here. I'll just do a quick copy, paste, and then change the word CS50.h. Now I'm going to clear my screen. And to clear your screen, you can hit Control L, for instance, which just keeps fewer characters on the screen for us. Make Mario 2. That worked. I didn't need to worry about the -LCS50 because, again, make does that for me. That's one of the features. And now I can do make Mario 2. Number, how many question marks do we want? So I heard 7 first, and now we have 7 question marks. And it's not necessarily going to look super pretty. If I do 700, now I'm going to get a whole lot. But look how quickly it did that for me. And so we have this power now of loops. So that's good. But you know what? I'm a little, let's see. What about this? What about -50 question marks? Is -50 an int? It is. So we will get it for you via the getInt function. But that's not really logically what we want. So think about it. On line 7, if n equals -50, how many times will the for loop execute? Why none? Yeah, because 0 is, in this case, greater than -50. So that condition never lets the loop actually proceed logically. So we're kind of OK. Nothing seems to happen. I get this sort of ugly blank line. And maybe that's arguably a bug. But at least it didn't like freak out the computer and just kind of print things infinitely many times, as could actually happen. So let me go ahead and actually, let's, well, the risk of losing control over my computer. Let's go ahead and change the logic. Suppose I change the less than to a greater than, and we initialize n to -50. And now is 0 greater than -50? Yes, and it's going to be that way for like a really long time, most likely, right? Even as you increment it. And so let me go ahead and do make Mario 2, and then hold my breath, and do -50. And like even the internet and the computer can't really keep up. And that's why you're just kind of seeing it bursty like this. We're sending thousands, tens of thousands, millions ultimately of question marks across the screen. And that too you might do accidentally. And so just as I did, you can hit the secret keystroke, which usually works, which is Control-C for cancel. And that will stop a program in the window from running. All right, so I've gone ahead now and implemented kind of a very weak approximation of this. So that's great. Let's now take a step up and consider not just this construct, but if we fast forward in the game to this part of the screen, now maybe we have a vertical block as well. And let's just consider for a moment, what about my code needs to change if I want to print 3 or maybe any number of vertical blocks? Like fundamentally, how do I want to change the code? How do I want to change the code? Yeah. Yeah, I just need a line break, where I accidentally almost did earlier. But in this case, it would be a good thing. So let me go over there, and let me just quickly make Mario 3 by starting at the same point. So Mario3.c. And then let me go down here and change this as follows. Let's make this I is less than n the way it's supposed to be. And just so that if we upload these later, I don't forget. And now I'll do a hashtag just because it looks more brick-like. It's not one of those coin things. And now I do this here. I don't think I need this anymore. So let me save that and run make Mario 3. Seems to be OK compiling-wise. Mario 3, number 3. And I get 3 of those. And now I can do maybe 5 of those. That works, and so forth. So there's still an opportunity for improvement here. In case I want to pester the user to actually cooperate, such that if he or she types in -50, I don't want to just like quit. Like I want to yell at them or somehow give them feedback and say like, give me what I asked for. How do I continue to pester a user again and again and again until he or she actually gives me the value I want? I'm sorry? While. So there's different looping constructs, while. And it turns out we could use while or even for, or there's another one as well. And let's consider how we might do this. It turns out that when you want to get user input from someone, you could use for, you could use while, but you'll find that it's a little annoying to use those constructs. Let me just jump to the better way first so that we see one other way. It turns out if you in a program want to do something at least one time, and maybe some more times, you could use for or while, but it's actually a little more straightforward to literally just do it while something is true, or while something is true. Now, this is just a placeholder. Let me start to fill in some logic here. So I want to do the following. Do the following while what? If the user does not give me a positive number, I want to prompt him or her again. The curly braces on lines 7 and 9 at the moment connote exactly that. Do this, do this, do this, while line 10 is true. So what Boolean expression, if you will, do I want to type in the parentheses here on line 10 to express the fact, keep doing this until the number is positive? Yeah? So while n is greater than 0, keep doing this. Which one? I heard less than. So OK, so let's rethink this. So while n is less than 0, ask the user for a number. Ask the user for a number. Ask the user for a number. And you know what? This is going to just confuse the heck out of them. Let's be even more clear with our prompt. Give me a positive number, but keep prompting him or her until we actually get a positive number. Now, if we really want to be nitpicky, it's actually not even less than. We're so close. It's less than or equal to. Unfortunately, I don't really remember having a key on my keyboard that's got like an angled bracket and then a line under it, like you might write in math class. So there's a way to do that nonetheless on your keyboard. I actually just do them side by side. This is less than or equal to. This would be greater than or equal to. And so now just get comfortable reading these things left to right. There's no special symbol like you would have in a math book or a homework assignment on paper. So this, I think, says the right thing. Do this while n is less than or equal to 0, which is, of course, not positive. And then down here, the rest of my code, I think, can stay the same. I just have a block of code up here now that's doing something. And you know what? This is where comments start to get useful. Prompt user for a positive number. And now down here, print out that many bricks. So, you know, it's kind of obvious if you just read through the code what I just said. But this helps you if you sort of sleep on it and wake up and you want to remember, why did I do this? Why did I do that? It helps the reader of your code, a colleague, a teaching fellow, and so forth. That's how you kind of start to add comments to your code. Unfortunately, there's a bug, and we're about to hit it. So let me try. Let me go ahead and make Mario 3. Oh, my God. More errors than I have lines of code, it seems. And this one's weird. Error, unused variable n. And now let me dive in deeper to these error messages, just so you start to notice little clues. So over here on the left is, of course, the file name, as you might have noticed, mario3.c. Then there's a colon, and then a number, and then a colon, and another number. Turns out this is just a very succinct way of saying that in mario3.c, on line 9, at character, or column, left to right 13, you've got a problem. At least the compiler thinks. So generally, the character is kind of sort of helpful. It's really the line number that draws your attention to the right place. Somehow, this is buggy. And specifically, the bug is that I have an unused variable n. And then very inexplicably, on line 11, now I have a use of n. So it's unused here, but it's used here. And somehow, the computer doesn't like this. Why might this be? Yeah. Yeah, that's the trick here. So it's a little different from Scratch, where when you make a variable, you can just use it anywhere you want. In C and some other languages, variables only exist in what's called a certain scope. And a scope you can generally think of as just the most recently opened and closed curly braces. So what does that imply here? Well, on line 9, I am on the left-hand side declaring a variable. Hey, computer, give me a variable called n. And it's going to store an int. That's the story we keep telling. But the problem is I am doing that in between lines 8 and 10, curly braces. And I claim today that that means, kind of like Scratch has these the hug the puzzle pieces, in C, variables are treated a little different. If you declare a variable in here, it only exists in here. And you can't use it down here in your code. And so this would kind of seem to be a catch-22. I need a variable, and so I can declare it. But I can't declare the variable there if I want to use it later. Like, it doesn't really seem to be a good situation. So just logically, even if you've never programmed before, if the fundamental problem is that this variable exists only in that scope of the curly braces, how intuitively could we solve this? Yeah? Remove the curly brace? Oh, move the curly braces. Yeah, we could move the curly braces, which is essentially the idea. The catch is the do-while loop really kind of needs them. At least in generally cases, you need those curly braces. But you know what? It's been a while since I typed them. but I do have another pair of curly braces that are sort of outside of, so to speak, my inner curly braces. So I have another scope here that's essentially the whole function called main. So what if I somehow declare my variable out there? And indeed I can. I can go to like line 7 or even higher, but generally you want to keep it as close to where you care about it as possible. I can type int n, and I don't think I want to prompt the user here, because then I'm going to create the same problem as before where I'm just prompting him or her once. I want that prompt in a loop again and again and again potentially. So that's OK. We've not seen this before, but you can declare a variable and then do nothing with it yet. Just say, hey, computer, give me a variable. I'll deal with this later. Just like in Scratch, you declare a variable if you did, and then you deal with it later as you want. Now, this would be a bug still. I can't say, hey, computer, give me a variable n, and then, oh, by the way, give me another variable n. So all I have to do to fix this issue is just don't redeclare it. Just use it. So line 7 says, hey, computer, give me a variable called n that's going to store an int. Line 10, same story as always, except it's slightly shorter. On the left-hand side, it says, here's my variable. Right-hand side says, here's a value we got from the user. Put it from right to left. And so now, because n is declared or created on line 7, it exists within the scope of these outermost curly braces. And now I can use it kind of anywhere I want, including on line 12, which is great, and most importantly on line 15. So let me go ahead and save this and do make Mario 3. Hold my breath. Good. It actually worked. / Mario 3, positive number. I'm going to give you -1. OK, I'm going to give you 0. Or fine, I'll give you 3. And now it actually cooperates. And so the do-while construct is still a loop. And Scratch doesn't really have an analog of this. But the do-while loop is still a loop, but it does something at least once. The difference fundamentally, though, is this. If I did this, like while n is less than or equal to 0, if I change this to a while loop, which we saw ever so briefly the other day as just an analog of the forever block in Scratch, if I do this, there's kind of a logical problem. Here's n being declared on line 7, so we're avoiding the scope issue this time from the get-go. But line 8 is saying, while n is less than or equal to 0. But what is n at this point? It's like not yet defined. And in fact, as we'll soon see in class, like it has some garbage value typically, some unknown value, remnants of whatever the computer used that RAM or memory for in the past. So this is like literally undefined behavior, it would seem. I don't know if the loop's going to execute or not because I don't know what's in n. So you could hack around this, so to speak. Hacking generally means like kind of sort of figuring out a solution to a problem that might not be the cleanest. And OK, let me just initialize it to like -1,000 because I know that's less than or equal to 0. So it's a hack in that it fixes the logical problem because now on line 8 is -1,000 less than or equal to 0? It is. So now my loop will execute at least once, and it will then change the value of n. But like, what the heck is -1,000 coming from? Like, these kind of inelegant solutions would be horrible, horrible design. Even though it logically gets the job done and it's correct, bad, bad design. And so that's why we started with a better design with the do-while loop. But you'll find there's many different ways to do things. And you might not, certainly in problem set 1 or 2, do things always the right or best way the first time. And that's OK, because with practice and experience, you'll begin to see patterns with which you can solve these same kinds of problems. Any questions on these approximations of Mario? Well, let me do one last one involving Mario, and kind of like this. I spent way too much time looking for parts of Mario that kind of painted these pictures, and I found these additional bricks underground in the fire level. And suppose I wanted to print like a cube of hashtags. So not just a horizontal line, not just a vertical line, but kind of sort of both together. And indeed, you can think of these bricks as exactly that. It's like hashtag, 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 and so forth. Kind of like an old school typewriter, printing one line at a time. And if you even remember typewriters, you can actually think of computers and printf as behaving very similarly. You can print something, then do the \n. Print something else, do the \n. So what is a square like this on the screen? Well, it's really just the process of like painting the screen, if you will, from left to right, moving down, left to right, moving down. And how do we do this? Well, what was the type of code we used in order to do something again and again and again? The for loop was the first one. We could use other constructs, but I'm going to go ahead and use the for loop again. Let me save this as Mario 4. as our fourth and final example. I'm going to keep this code up here because I still want to prompt the user for some number of blocks, a positive number at that. And now I don't want to just do this, but let me just see where I left off. Let me go ahead and make Mario4 ./Mario4, and let's do like a 5 by 5 block. OK, that's just a column. So I've got to do a little more. Well, it turns out that just like in Scratch, I can take one idea and kind of nest it inside of another. Let me go ahead and do this. How about inside of my for loop that's going from I to n, let me do another one for int. And I don't want to reuse I, because I feel like if I use I in two places, something's going to get messed up. So I'm going to go with the next one alphabetically, j, which is actually pretty common. So int j gets 0, j is less than n, and j plus plus. And now in here, I'm going to put that brick. I think I need to get rid of this here. And let's see now what happens. So I've got a for loop inside of a for loop. If I go ahead and do make Mario4, enter, code is compilable. ./Mario4, let's type in 5. I think that's actually like 25 if I really count it out. That's not what I wanted. I wanted a square. So what's obviously missing aesthetically? A new line, but I kind of thought that doesn't go here. Right? Because if I do this, just real quick teaser, if I rerun Mario4 after making that change, now I've just made the opposite problem. So what needs to change? Yeah. Oh, just scratching? OK, what needs to change? Yeah, over here. Yeah, and what line would you propose the printf with \n? Sorry? 21. So like above or below it? Above it. OK, so let me go there. So let me go ahead and printf \n. And now let's see. So make Mario4 ./Mario4 enter 5. Beautiful. Beautiful. It's not quite a square on the screen because like the hashtags are a little more vertical than they are wide, but that's OK. We've built this sort of approximation of that level too. And now, just for good measure, let me just think about it. This is kind of an oversimplification. Print out that many bricks. So print out this many rows or columns on the outside. And then in here, where we're going with this, print out this many. What should my comment here be? On the tops. Top one is rows. And then down here, this should be columns. And it is. Because on the outermost loop, you've got I, and it's starting at 0, and it's eventually going to 5. But whenever I is 0 at the beginning, it's like the cursor is in the top left-hand location by default on the screen. And then you've got this nested loop, which says, oh, by the way, do the following 5 times. What are you doing 5 times? Hashtag, 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 hashtag. Then a new line. Then I becomes 1. So it's like moving over. Then I becomes 1, which means you're now on the second row because you've printed out one of those new line characters. So here, too, this is where comments would be helpful because, frankly, even I had to think about that. And you don't want to waste time thinking about code you've already written. Just give yourself the answer to why you made past decisions, as in a case like this. All right, so suppose something's going wrong. And in fact, we already solved the problem of like a lot of hashtags going this way and a lot of hashtags going that way. But suppose you want to wrap your mind around what your code is actually doing. It turns out that we have 2 other tools we can use. It turns out we have in the CS50 library a function that's almost identical to printf, except we called it eprintf, or like error printf, just to help you see what's going on inside of your code. And you should use it as follows. If you kind of want to wrap your mind more clearly around what your own code is doing, or for that matter, even an example from class that you downloaded, you can add certainly your own lines of this, like, hello there, I'm at home playing with this code, or something like that, right? So something nonsensical, but at least now, when you see that sentence on the screen, you know on what line the computer was executing your program. So you can be a little more methodical than this. And with eprintf, notice we can do the following. I'm going to change this to just eprintf, and it works the same. And I'm going to go ahead and do this about to prompt user for a number. Like I just want to provide an explicit note to myself temporarily what should be happening here. And let me see now what happens. If I do make Mario4, OK, ./Mario4, I get a little ugly output, but it's just diagnostic. It's temporary. It says Mario4.c on line 10 is giving the following message, about to prompt user for a number. That's just a note to self so that I'm comfortable understanding the flow or the structure of my program. I can still interact with it. Let's type in something like -1. And what should I see next on the screen if I type -1? Yeah, another problem. About to prompt user for number. So it's just like a sanity check. Like if you think something's going to happen, tell yourself that it should in your code and make sure you see what you expect to see. And then once you're sure your code is good, then don't submit it with this because this is not like correct per the specification. You can just get rid of it at that point. But frankly, that gets tedious very quickly. Oh, and how do I kill my program if I don't want to keep playing? Control C will terminate the program. There's one other tool, perhaps the most powerful, and I can't stress this enough. Get into the habit of using this as needed early on. Even if it takes you an extra 10 minutes, half hour to play with it, it will save you potentially hours over the course of the semester. And that is a program called a debugger. So a debugger is a program that helps you remove bugs or mistakes from a program. And it works like this. I'm going to go ahead and recompile Mario 4. And now I would normally run it, of course, with /Mario4. But suppose I have a bug, and I really want to understand what's going on. I'm going to do the following. You'll notice that all of my examples thus far have line numbers in the so-called gutter of the program, left-hand side. And it turns out you can actually click to the left of those numbers at like this point here. And you can put a red dot. This shall be known as what's called a breakpoint. This is like a little stop sign, only for yourself, that says, hey, computer, pause my program here, or really stop my program here, like a stop sign, temporarily. And let me, the human, go at human speed, not like billions of things per second speed. And by this I mean the following. I'm going to now run not Mario 4, but debug50 space Mario 4, which again is a program we wrote that invokes or starts the IDE's built-in debugger. So notice magically, this right-hand panel just popped out. And it's actually always been there. It's always said debugger. And it just happened to open that window for me automatically. And let's see what's going on. There's a lot of words, but we're familiar with many of them already. Notice that down here is the word local variables. And then there's kind of a table here. It's not very big because I only have one local variable. And at this point in the story, my variable n happens, I got lucky, it has a default value, it would seem, of 0. I shouldn't rely on that, but it's just so early in my program that it seems safe that it's, it's so early in my program that it happened to have the value 0 in it for our purposes today. And it's of type int. But what's cool now is the following. Now notice that my program is effectively paused on line 7, or specifically line 10, which is the first interesting line. That's why it's highlighted in yellow. And what's cool here is this. Up here in the top right, you have a play button, which will just say, play the rest of my program. Just let it go through without pausing. Or if I hover over this thing, you can step over this line, which means, hey, computer, execute this line, but at my human pace, just one line of code at a time. If you're really curious, you can step into that line of code, but more on that in just a moment. Meanwhile, this is step out, which is if we've actually dived in deeper. So what do I mean by all of this? So I'm currently paused on line 10, which was the first interesting line of code in my program so far as the debugger is concerned. I'm going to go ahead at top right, and I'm going to go ahead and click step over. And notice my terminal window is now prompting me for a number. Why? Well, because I've stepped over the getInt line, which means execute it. So let me go ahead and type in that number. Let me go ahead and type in -50, enter, and keep an eye on the variable on the right-hand side. Notice now in the debugger, even without printing it with printf or eprintf, I can see that n has a value of -50. It's just a sanity check, so to speak. I can see what it is to be sure it's consistent with my expectations. All right, that's not right, so let me go ahead and step over. And notice the yellow line moved because it's looping. You can literally see what I keep doing with my hand. Let me do it again. OK, positive number. I'm going to cooperate this time, 42. Enter. Notice at the right-hand side, the value n is indeed 42. And notice the yellow line, if I keep stepping, is about to jump to the next interesting line of code. And if I keep doing this, watch what's about to happen in the blue terminal window at the bottom. There's the first hashtag. There's the second hashtag. So the sort of fake animation I did the other day with just my slides and what I try to do verbally and with my hand going back and forth, you can now see much more methodically. So even if it's a simple program, and even if it's code you wrote, you can really see step by step what it is your program's doing. And maybe it's not doing what you expect. And if it's not, you'll see it visually. All right, now I'm just going to go ahead and say, OK, print the rest of the thing. So I hit play. You see that the GDB, the GNU debugger server, is exiting. It's just quitting. And now I'm back at my prompt, and the debugger goes away. So do not undervalue those particular tools. So before we forge ahead, I thought I'd introduce Abhishek here, who you might have seen on the internet just a couple months ago. He kind of went viral. He's a recent grad from NYU. And he did this extraordinary thing. He took a device called a Microsoft HoloLens, which is an augmented reality device. It puts sort of a goofy-looking screen in front of your eyes, but then it projects images in front of your eyes. And it's really cool in that, much like an Android phone or an iPhone these days, it helps you, it knows where you are in a three-dimensional space. And what Abhishek actually did was he went to a very three-dimensional space, Central Park in Manhattan, and he had before that spent days recreating Super Mario Brothers in augmented reality by recreating one of those maps to which I alluded earlier. And the end result, and I'll show you just a glimpse of it, and we'll put it on the course's website for you to see later in detail, was this, which is pretty mind-blowing and a wonderful application of computer science to the real world, literally.
Hi, I'm Abhishek, and I've recreated the iconic first level of Super Mario Bros. As a first-person, life-size augmented reality game that I'm now going to play as Mario.
Abhishek gave a tech talk in CS50 a couple of months ago. And the funniest part, if you really look closely, and it is Manhattan, is like some people look at him, but like a lot of New Yorkers don't even look twice at what he's doing. Let's go ahead here and take a 5-minute break. And when we come back, we'll begin to look at the world of cryptography. So we are back. And of course, there are more functions than just printf. And we've seen a glimpse of these by way of the CS50 library. And there's many, many, many more that come with C itself and that other people around the world have written over the years. But implied in each of these CS50 functions, notice are these keywords like string and int and float, which we talked about the other day too, long and long and double, as we saw the other day too. So it turns out that C, to be clear, has what are called data types. And we glimpsed this the other day. Data types specify what type of data you can put inside of a variable. And that's what's different from Scratch too. In C and a few other languages too, you have to decide in advance as the programmer what kind of data are you going to put in this variable so that the computer, or really the compiler, knows. And so the compiler knows how to deal with it for you. Well, it turns out that if you want to print these things out, printf also comes with certain format codes. And we've seen %s for strings and %i for integers. And there's a bunch of others too. Perhaps the most common would be these, just so that you've seen them. %f for float. We saw that the other day. %lld for a long decimal number. That's one I often have to look up myself. And then there's even more of those too. So just realize that as you're getting input from the users, whether for problem sets or any other purposes, realize that sometimes you have to check the manual or the documentation, so to speak, for functions that you're using. And so that you know where to turn for those kinds of things, let me just introduce one thing real quick. And you'll see more of this in super sections and sections and beyond. If you forget, for instance, how certain functions work, you can actually type the following. Man get underscore string, where man stands for manual. And this is kind of an old school command on Unix and Linux computers that have this text-based keyboard environment. And you'll see pretty much a standard structured user's manual for the function in which you're interested. So if you forget what we talked about in class, or you're not really sure how else you can use it, and the function is something like getString, you can simply read about it here. But sometimes, frankly, it's going to look a little arcane. I mean, we have not talked about what some of these symbols mean. The ... the word const, the asterisk that I've highlighted on the screen. So frankly, sometimes you will find the man pages, as they're called, the manual pages, just confusing unto themselves, which is a nasty situation to be in. If you're already confused and the documentation is not helping, you kind of need a third option. And so if you go to CS50's website, you'll actually find that there's a link to a tool that the staff has created over the years called CS50 Reference. This is a more user-friendly version of those same man pages where we've gone through and sort of translated the very arcane English into less comfortable English, if you will. So if over here I scroll down to, say, printf, or rather let me just search for it, I can see printf here. It's inside of this header file, this H file on the system. And now I can actually read about it here. And notice at top right, checked is the less comfortable box, which means, hey, show me the language the TFs came up with as opposed to the default language. But it too is meant to be a training wheel. So if and when you're ready to sort of take away some of those simplifications, you can uncheck that box and now see the much more verbose technical version that you would actually see in the real world. So keep in mind those kinds of things too, especially if it feels like we go through things quickly in class, which we do, and you need to lean on something authoritative thereafter. But let's tease apart what actually a string is. Let me go ahead and start actually with Stelios here. So Stelios, one of our head TAs in New Haven, has this name here. And I've written it as a string, S-T-E-L-I-O-S, but I've kind of drawn boxes deliberately around his name to capture the fact that this thing we call a string, like Stelios, is actually not really a string only. It's really like an abstraction for something a little lower level, which is a character after a character after a character and so forth. And so here too we see an example of an abstraction. Like it's not that much fun to call Stelios S-T-E-L-I-O-S. We call him Stelios. But we in languages like C would call that construct a string, or more technically a sequence of characters. But it's a string. It's a nice abstraction. It's a nice simplification. But it turns out there's an opportunity here now to see how characters and numbers interrelate in a computer and see how powerful computer programs and software are that we ourselves can write. But first, how do we access individual characters in a name? I can easily get Stelios' name using the function getString, as we've seen, just like Sam did from the audience the other day. But how do I actually get it like the S or the T or the E? Or if maybe he makes a typo, or maybe he doesn't type it very neatly, how do I capitalize his name or sort of clean up his user input like websites today very commonly do? Well, let me go ahead and open up CS50 IDE again and just do a pretty simple example that this time involves strings. Let me go ahead and create a new file. And I'm going to call this file string0.c. And I'm going to go ahead now and write a short program. Come on, once I've lost control over my terminal window. Now I've lost control of my menu. This is my own fault for oh, here we go. Well, this is going to look great. Very inspiring here. Where'd it go? Oh, here. OK, that's an example of bad design. So we will fix that. And now I see that I've misspelled string as strig. So we're just going to, no one on the internet will ever know the following happened. OK, so string0, voila, here we go. All right, so string0.c. And I'm going to whip up a really quick program here as follows. So int main void. And now string s gets get string. And I'm just going to ask for the user's input in this way. And now I'm going to go ahead and print out, how about just say the word output here. And just to be nice and tidy, let me put a couple spaces here in anticipation. And now let me go ahead and do this. On line 5, my intention is to get like Stelios' name from him or whoever's playing this game. But now I want to go ahead and not just print out like hello Stelios and plug in his value s, which we've been doing. I want to do this character at a time. And doing something one at a time kind of suggests a loop. And indeed, I can do that. So I'm going to do for int I gets 0. I is less than however long his name is, and then I plus plus. And now I can introduce one other trick that you can kind of glimpse ever so quickly from the screen I had up before. Turns out that %c is the placeholder for a character. Perhaps no surprise. But the catch is I only have access to s, the whole thing, the string s. But it turns out there's a new piece of syntax here. And as is kind of sort of implied by our having used boxes to flank Stelios' letters of his name there, turns out that the equivalent in C is to kind of sort of do the same, use a box of characters by using the square brackets, which you might not often use on your keyboard. On a US keyboard, they're often just above the Enter key. And here I can go ahead and type in s bracket I. And so to speak, this is going to print the ith character, if you will, of Stelios' name. So I is going to start at 0. and I keep doing plus, 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 and using this square bracket notation, so to speak, I can dive into the individual letters in his name in this case. So when I run this, what's going to be the net effect? Let me go ahead and make string 0. OK, that does not valid C code, however long his name is. So I have a problem to solve here. How do I actually get the length of his name? Well, I can kind of cheat. So like, OK, so 1, 2, 3, 4, 5, 6, 7. All right, so we can just write this program as follows. 7, but this should rub you the wrong way. Like, why is this not a good solution to the problem? Yeah. Exactly. It's not changeable. I have this dynamism of get string to get Stelios' name, but 7 is not going to be true of all the humans who might use this program. I need something dynamic. Well, it turns out there is a function for that. I can call strlen for string length, pass in as input the variable whose length I want to get, and that will return to me a number, which will be, in this case, it would seem 7. But it's going to be dynamic, so if I type in like David, that should return 5, hopefully, and any number for any number of other humans engaging in this. So let me go ahead now and try again. Make string 0. A lot of errors and use of undeclared identifier string. Wait a minute, we've seen this before. How did I solve this last time? Yeah, what's up above missing? Yeah, the libraries, or the header files, so to speak, for the library. So I need to include, I'm pretty sure, at least standard.io.h for printf. I need to include CS50.h for getString. And we're almost there. Let me see if that's enough. Make string 0, implicitly declaring library function strlen with type. I don't really know what that is, but there's kind of an answer hinted there. Include the header string.h. and so forth. So turns out this is true. And you know, there's different ways to know this. If I actually go back to reference.cs50.net and do strlen, there's that function. Let me go back to the less comfortable version. Notice that under synopsis of a man page, or reference.cs50.net, is always a quick summary of how you use it. So just the prototype of the function that gives you a sense of what it is. Size t is essentially equivalent to an int, just saying the size of something is a number. But include string.h is the ingredient I wanted. So let me go ahead and copy that. Let me go back to the IDE. I'm going to be a little nitpicky, and I'm just going to keep things alphabetical at the top, but that's not strictly necessary. It just makes it easier to skim later on when the list gets long. Make string 0. Seems good to go. /string 0 inputs. Now I'm going to go ahead and type in Stelios' name, and I got his output as well. Now that was a lot of unnecessary work to print his name. I could have just used %s, but now I can make modifications. What if I wanted to print it 1 per line? I can add that. I can make the program again, rerun it, and type in his name, and now I get it 1 per line. It's a little ugly, like now it says output s, but that's just an aesthetic bug. I could go in and fix that, but now I have control over the individual characters in his actual name. So that would seem to be progress in some form. But if I now have access to the individual letters, we can kind of come full circle from the very first lecture where we talked about zeros and ones, and then numbers, and then letters, and now in turn words, otherwise known as strings, by way of a topic called typecasting. Types, of course, are the types of variables we've been talking about. Casting means to convert from one to the other. And if you might recall from the first lecture that capital A was the number we know in decimal is 65, and whatever pattern of zeros and ones that is. Capital B is 66, and so forth. So can I see that now for the first time? Well, it turns out I can. Let me go back to the IDE, and let me go ahead and create a new program called ASCII 0.c. And ASCII, again, is just the standard. It's an acronym, American Standard Code for Information Interchange, which maps letters to numbers and numbers to letters. So let me go ahead now and whip up a quick program. Include standard.io.h for printf, int main void, and then let me go here and do the following. You know what? I'm going to just go ahead and print out, let's say, string s gets get string. Let's just ask for someone's name. And then let me go ahead and do the following. For int I gets 0, I is less than the length of that string, learning from last time, I++. So this is going to iterate over the whole string. And now what I want to do is this. Let me go ahead and print out the following. Let me print out the character itself, and then a space, and then how about an integer? And then a new line. And we'll see what this does in just a moment. I want to plug in values for these placeholders. So how do I get at the first character of the name if the string is called s? Yeah, so s bracket I for the ith character. And that's going to plug in literally S-T-E-L if Stelios is the one playing the game. But now I put a comma to plug in a second placeholder. And %I. You know what I'm going to do? I'm going to do int in parentheses s bracket I semicolon. So it looks a little cryptic, but let me just remove this for a moment. This is just the same thing twice. Print the ith character of the name, ith character of the name. But in parentheses, I'm doing what's called typecasting. I'm taking whatever that is, which is a char or character, and I'm saying, parenthetically, make this an int instead. So if it's capital A, it becomes 65. Capital B, it becomes 66, and so forth. And if I now run this program, or compile this program, after preemptively fixing what would have been a mistake by adding the header, make ASCII0.c. Oops, sorry. Oh, common mistake. Nothing to be done. I'm pretty sure there's something to be done. I need to compile it. What did I do wrong? Yeah, don't put the .c. It's a little counterintuitive, but when you want to make a program, you type the name of the program, not the name of the file. Now oh, damn it. I almost learned from my mistakes. What am I missing now? String.h. All right. Include string.h. Save it. OK, so let me make ASCII 0. Good. / ASCII 0. And now Stelios. Enter. And now we see the ASCII codes, or the numbers that correspond to the letters in his name. They're pretty big numbers. They're in the hundreds now. And that's because they're lowercase. We've previously talked only about capital A, capital B, and so forth. But it turns out that the lowercase letters also have values associated with them, like some of those here as well. And now it turns out, now that I know this, now I can kind of do like some low-level stuff that we all take for granted on our phones and websites, like when you just type in your name in all lowercase and the website just fixes it. Or if you type in your phone number in with parentheses, without parentheses, with dashes, without, the website just kind of fixes it and cleans it up into some cleaner format. We now have kind of the low-level control to do this. I won't type this one out manually just because it's a little longer. Let me go ahead and open it up. Among today's examples, in source 2, which is on the course's website, is this example here, capitalize 0. So let me make a little more room for this. It's a little longer, but let's just focus on just a couple lines at a time. Here's the beginning of my program main. Here's a line of code where get string before. I just said, give me the before string. And then I claim, now print the string after, making some changes to it. So what am I going to do? On line 11, I seem to have used the same idea as a moment ago, but with one change, actually. I've done something a little different. Line 11 is very similar to what I've been doing to iterate over the characters in a string, but I did something different, which is what? What looks different now versus what was on the screen a little bit ago? Anyone a little farther back? Yeah. Yeah, it looks like I'm declaring two variables all in like the same breath, so to speak. I have my int I equals 0, and we've done this a bunch of times. But then I have a comma here for the very first time, n equals strlen of s. But if you think about what these building blocks are, OK, the comma is new, but n is on the left, so that's a variable apparently. It's probably an int because the word int came before. Equal sign is assignment from right to left. Strlen is a function that returns the length of a string. So this would seem to be storing, just to be clear, what number in n? Yeah, the number of characters in whatever the string is the user typed in, Stelios or David or whatever the name is. So then I have my condition. Then there's the semicolon, which we have seen. And then there's ++. So I claim that this is, in a sense, better design. It's a little more complicated. Like I typed out more characters. I added another variable. But why might it be smart and good design to have used an extra variable, using a little more space to keep a number around, so as to then simply compare I against n? Like, why did I jump through these hoops? What do you think?
Because then it doesn't have to check what n is each time it goes through the loop.
Exactly. It doesn't have to check what the length of the string is on every iteration, because after all, once I or Stelios or whoever types in their name, it's not going to change. It is DAVID or Stelios' name or Maria's name or whoever is playing the game. And so why would you keep calling a function saying, oh, by the way, what's the length? By the way, what's the length? What's the length? Just remember it the first time, because odds are it takes a little bit of time to do that computation and actually figure out the length. And so here, we've simply kept that answer around in n and can compare two variables. Meanwhile, here's a pretty big if-else construct. But if we break it down into pieces, it's doing something relatively simple. On line 13, I am asking the question, if the ith character of s is greater than or equal to a lowercase a, ampersand, ampersand, which we haven't seen before. This means logically and. So if it's greater than or equal to a and less than or equal to z, put another way, if it's between a and z inclusive, in lowercase, what am I doing on line 15? Which is super weird looking. I'm first printing out %c, which is my placeholder, but then I'm printing out the result of s bracket I minus whatever lowercase a minus capital A is. I mean, this is just strange now, but let me just point out one clue. Turns out there's a pattern here, and humans did this deliberately. If you can do the arithmetic quickly, how far apart is lowercase a from capital A? It's 32, right? And you can just do the math, like 97 minus 65, oh, 32. How about capital B versus lowercase b? It's 32. 32, it follows this pattern. So this is to say, and it's sort of proof by example, like we're not even seeing all the way to z, but trust me, 32 is invariant across all of the letters of the alphabet. They're always 32 away. And I could hard code 32, but that feels a little inelegant. Why don't I instead just arithmetically say whatever the difference is between lowercase a and capital A, and that's all I'm saying in parentheses here. Whatever that numeric difference is in the computer's representation of my numbers, just subtract that difference from the ith character. Now what's nice is I kind of sort of should do this first. Like I should cast the character to an int, but I don't need to be so explicit. Like the computer knows that characters are integers, and the computer knows that integers are characters. There's this equivalence. I don't need to be so verbose as to even say that. It just suffices to let the computer figure it out implicitly that in this context, I'm doing arithmetic on numbers, and then in the context of printf, I'm displaying that number as characters. Like nothing is happening. You're just telling the compiler what context in which to treat these values, numeric or characters. So long story short, what does the effect of these 4 lines of code have on the characters in the user's input? What does it do? It capitalizes it, right? It capitalizes it, and that might have been implied too by the file name in full disclosure, but it's how you think about solving the problem of capitalization. Here's the string, home in on the individual characters, figure out if they're within a range you want to deal with, and if so, do some kind of mutation of them to change from one value to another. I could have done this a horrible way. I could have had like an if, else, if, else, if, else. I could have like 26 conditions checking is the character A. Is it B? Is it C? And if so, make it capital A, capital B, capital C. But that code would have been like this big or bigger. This is now a more algorithmic way of solving the same problem. And if it's not a lowercase letter between A and Z, just print it out. Like there's no work to be done. Now, just so you've seen it, it doesn't have to even be as verbose as this. In capitalize 1.c, which is available also on the course's website, I've made my code a little better designed. I'm now not reinventing as many wheels. I'm standing on the shoulders of smart programmers before me. And I've clearly changed at least one thing. Instead of doing this manual process of comparing against lowercase a and capital and lowercase z, I'm just punting and using a function, which beautifully is called isLower, which just literally answers that question. Because another data type in C is not just int and char and float and string in CS50's library, but there's also something called a Boolean. A Boolean, also named after bool, is similar in spirit to a Boolean expression, true or false, but a Boolean variable is literally just the idea true or false. And so isLower you can think of as returning a Boolean value. It returns true or false, yes or no. And the name of this function, therefore, is very appropriate. isLower, that's a yes/no or a true/false question. I don't know how it's implemented. If I really care, I could go to CS50 Reference, or I could use the man command on the IDE, and I could actually check how this thing works. But I do need one takeaway. To use this, I need to use the C-type library. So there's other libraries that we're now just scratching the surface of, and you would only know they exist by reading documentation like that. But you know what? I can go even further. You know what? If some human years ago wrote a function to check if something is lower, what did he or she probably do as well for me? Yeah, is upper. Also, it does exist. Yeah, so spoiler here. So is upper exists. But if they checked if it's lower or is it upper, I'm going to just go on a limb. 2-upper? Yeah. So it turns out there's a function called 2-upper that converts a letter to uppercase. And indeed, I can now leverage this in my third version of this program as follows. Capitalize 2.c gets even better designed still, if you will. It's even shorter, fewer lines of code, easier to read, fewer opportunities for bugs. How do I solve it now? I still iterate over each of the characters, but I just blindly call 2-upper on every character because I read the documentation. If you pass a character to 2-upper that is already uppercase, it just prints it out, doesn't change it. If you pass in a punctuation symbol, it just passes it through. But if you pass in a lowercase letter, it capitalizes it for you. And so I can now kind of I can lean on whoever implemented that before me. It could have been me. I could have wrote my own function called 2-upper, but I don't need to because in the world of programming, there exist libraries of code that other people have written for us that we can leverage. Any questions then on that? Yeah?
So this method, you wouldn't be able to capitalize as the first letter. It would be all of them.
This would be all of them, yes. So if I only wanted to capitalize Stelios' the first letter of his name, I probably wouldn't want the loop. I would probably just want to capitalize bracket 0 specifically of the letters, but I'd want to make sure that his name is at least one character long, lest he just have hit like enter accidentally or maliciously. Absolutely. So let's just dive in to one other detail here as follows. Suppose that I want to actually know what the length of a string is. I know that there exists this function called strlen, but it turns out I can figure out lengths of strings for myself too. Let me go ahead and write a program called strlen itself, but I'm not allowed in this example to use string length. I'm going to go ahead and include the CS50 library. Let me include standard.io.h. Let me go ahead and do int main void. And now let me go ahead here and do string, bad style, string s gets get string name. And now let me go ahead and do int n equals 0. Just give me a variable, call it n, set it equal to 0. And then let me go ahead and while I'm not at the end of the string, also not valid code, n++. I can use that ++ trick that we've seen before for I++. And then I'm going to go ahead and print out whatever the value of that counter is, because I want in my loop to just count the number of characters in Stelios' name, or whoever's name actually ran the program. And just to be clear, this is what's called syntactic sugar, which is a very sexy way of just saying this is shorthand notation for doing this, which is just boring looking. This does the exact same thing. It's just a more succinct way of doing it. And you'll see little features of languages like this just to save us humans keystrokes. This, of course, is not a solution to a problem. How do I know I'm at the end of the string? Well, it turns out we need to break the abstraction layer, so to speak, of strings just a little bit. So it turns out that in your computer, we have this piece of hardware, RAM. And we saw this the other day. And we talked a little bit about the limitations of computers and the finite amount of memory that they have. And if you think about all of the chips on this device, doesn't matter for today how this works, but just know that there's lots and lots of bytes that can be stored in your computer's memory. And you might have 1 billion bytes, 1 gigabyte, 2 billion bytes, 2 gigabytes. But for our purposes today, just think of this RAM inside of your computer as just a long list of available bytes. Lots of bits, zeros and ones that you can change the values of. And maybe it's kind of a grid. So there's lots of bytes horizontally, lots of bytes vertically. We can kind of number them all so that one of the bytes is 0 and the other one way at the bottom is like the 2 billionth byte. So just assume that we can number all of the bytes in our computer's memory. Well, it turns out that when you type in Stelios' name, it of course ends with an S. But it would probably be a stupid decision to just look for an S when figuring out the length of someone's name, because it's not going to work on my name, it's not going to work on Maria's name, or any number of other people in the room. So we don't know enough yet about what's going on inside of the computer's memory. It turns out that if you think of this grid now as your computer's RAM, maybe top left corner is byte 0, the one next to it is byte 1, then byte 2, then ... byte 2 billion. So I'm just arbitrarily depicting it as a two-dimensional grid. Turns out we need to know that there's this special character. What C does for us, even without our telling it to do, it always puts a secret number at the end of any string the human types in. It's specifically represented as \0, but that's just the special way, like \n is special, of saying that is 8 0 bits altogether. It's a special value 0. And so now that we have this so-called sentinel value, if you will, sentinel value means this is just special. The human can't really type this. Like I can't actually type all 0 bits easily on my keyboard because honestly, even if you hit the number 0, that is technically the character 0 because it turns out even numbers on your keyboard map to different integers. But more on that another time. So 0, 0, 0, 0, 0, 0, 0, 0 as bits are what that is. And so if I write a program that calls getString multiple times and Stelios is the first one to type in his name, it might end up in memory looking like this. But then suppose one other person types in their name, like Maria, her name is just going to fit in the next available memory, but also be null terminated, so to speak. The sentinel value is also called null, N-U-L, but that's just all zeros. And then if someone else types in his or her name, it's still going to fit in there. So Zamila, for instance, it wraps around, but again, this is an arbitrary artist's rendition of my computer's memory, ZAMYLA \0, and I can keep typing in names until I'm just out of memory. At that point, like the program's going to crash, or I'm going to have an if condition that says too many things in memory. Something's going to have to stop at that point. So what this means for my implementation ultimately is the following. I can now go ahead here and change this silly English to the following. While the nth character of the string does not equal quote unquote \0. And I'm using single quotes this time because recall from last time that we use single quotes anytime we talk about single characters. We use double quotes anytime we're talking about strings. And even though s is a string, s bracket n is the nth, or ith, doesn't matter what letter we use, the nth character. So that's a character, and so we now need to use single quotes. So this is really just doing the following. It's initializing n to 0, and then it's looking in memory, and it's saying, is this \0? If not, increment n by 1. Is this \0? No. 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 Damn it. No. No. Yes. And at that point, I have 7 fingers up. Or n is storing the value 7, that's what my program is going to print out. So now we have a complete program that counts the number of characters in a string. I don't need this program because strlen exists as a function, but it's now a capability to which I have access. Any questions then on what a string really is underneath the hood as this sequence of characters with a special null character at the end? Yeah? Good question. What about other data types, if I can rephrase it, like ints and floats and so forth? Actually, strings are special. If I scroll back to the list of data types that C has, for instance, most of these are of fixed length. And this is why the compiler needs to know what you're putting in them, because the compiler and the computer in turn need to know, is it 1 byte? Is it 2 bytes? Is it 4? Is it 8? Like, how many bytes should I look at? Strings have no predetermined length because, of course, we don't know who's going to type in their name. But an int, turns out, in most systems is always going to be 32 bits, or maybe 64 bits, or equivalently 4 bytes or 8 bytes, because there's a 1 to 8 ratio. A bool is often 1 byte. It's a little wasteful, even though technically you need 1 bit. It's just easier to deal with 8-bit increments. Chars are, by definition, 8 bits or 1 byte. So almost all of the data types are a fixed length. So you don't need to have a special null character, but strings you do. Strings are special. Other questions? All right, so what can we start to do with this? Well, it turns out that this idea of thinking about things that are back to back to back to back as being individually accessible is actually a very powerful idea. Because up until now, we've just had this list of data types, bool and float and char and ints. It's kind of a short list of very primitive things. But it turns out, if you want to write a program that doesn't just keep asking for 1 name, but asks for 2 people's names, or 10 people's names, or asks for, as you asked earlier, the name, or like maybe their house, or their dorm, or their phone number, their email address, like a whole bunch of different values, it would be nice to kind of store multiple things together. And one way you can store multiple strings is you could call one string s, you could call the next string t, you could call the next string whatever. You could just come up with arbitrary names for your strings, but that's going to very quickly devolve. Imagine like what the registrar uses here at Yale to actually keep track of students. Like, they don't have a computer program with thousands of variables inside of it. They probably have a computer program for dealing with course registrations with at least one variable called students. And inside of that students variable, can the registrar fit 1 student, 10 students, thousands of students? It can kind of grow to fill the number of values we actually care about. And C isn't quite as powerful as that. We'll need another language like Python or JavaScript to really get dynamism. But for now, we do have the ability in C to represent multiple things back to back to back to back to back in memory. So not just characters in strings. We can borrow that idea from strings and store, if we really want, student, 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 like multiple strings back to back instead of just individual characters. And what that idea is called is an array. An array is a contiguous chunk of memory, something back to back to back, literally physically next to each other, typically in the RAM that we've presented as hardware. But it's not just character, character, character. Maybe it's int, 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 or string, 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 or more generally, student, 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 multiple things back to back to back. And so now we can actually give you a glimpse of what this thing here is that we keep typing sort of on faith. Int main void literally says that your main programs that you're about to start writing for PSET 1 and beyond will be returning an int, even if you don't do it yourself. They're going to return by default 0, it turns out. And we'll see before long why this is useful for a main function to return a value, even though we humans will rarely, if ever, see that value. But it is interesting to note that main can take input, and not input in the sense of get int and get string and so forth. You can actually provide your program with input at the so-called command line. Like all this time, I've been typing /Mario0, /Mario1, and no words after that. And yet, we've shown you Clang already, the compiler itself, which can take in like -O and then -L CS50, like all of these additional keywords that somehow influence its behavior. So wouldn't it be nice if I could write a program where I don't prompt the user eventually for his or her name. Let me just let them type their name at the command line and hit enter once and be done with it. Just like Clang is just one long command and you're done with it. There's no prompts. Well, we can do this if we change void to this. And it's a mouthful, but there is an alternative version of main that does not just take 0 arguments. That's what the keyword void all this time has meant. It just means main takes no input by default. You have to prompt the user explicitly with get int or get string or whatever. But there's an alternative second version of main in C that takes 2 inputs. And you don't have to provide them explicitly. We'll see how to use this in a second. Main can also be handed 2 inputs. One is an int, and one is an array of strings. The int is the total number of words that the human has typed at their keyboard. The argv, argument vector by convention, though we could call it anything we want, that is an array of words that the user typed at the prompt before hitting enter. And so this is useful in the following way. I'm going to go ahead and in today's source code, open up an example called argv, for argument vector, 0, as follows. In argv0, there's not all that much going on. And if you at least kind of take on faith the concepts here, you can perhaps infer what's going on. So I've changed what main looks like on line 6, the signature of main, so to speak. And then I'm asking a question. If argc equals 2, then print out hello something. Otherwise, just print out the hard-coded hello world. So it looks like argv1 is kind of being treated like we were treating strings a moment ago, but this is the special syntax that's new. If you use square brackets like this, like I've done, with no numbers inside, that's like telling the computer, hey, computer, this variable argv is going to be an array of some length of strings. Why strings? Because string is the word immediately to the left. String, argv0, open bracket, close bracket. Now, I don't know how the strings are going to get in there. The computer is going to do that for me, but it gives me this capability. Let me go ahead and compile this program as follows. Make argv0 /argv0 hello world. Uninteresting. But if I now type in my name at the prompt and hit enter, now it's dynamic. So what must this mean? Even if the syntax is a little new, we can kind of infer now what this must be doing. argc happens to stand for argument count. So argc equaling 2 apparently implies that the human typed 2 words at the prompt, the name of the program and then whatever else he or she typed. Meanwhile, argv, argument vector, is the variable that you can use to go get the first word or the second word, or if there are more, the third and fourth words. In fact, if I kind of change this manually, what should probably be, by that logic, in argv0? Yeah, like the name of the program, right? So let me see. So make argv0 /argv0 David, hello, OK. I mean, it's stupid looking, but that's all I'm doing. I could be a little bold and say, what is in the 100th location of this array or list, as you can also think of it? Make argv 0, / David. Oh, that is bad. And get used to this, because it will start to happen with greater frequency. Segmentation fault is a very cryptic way of saying you touched memory, RAM, that you should not have. And you can kind of think of what this means. So if argv 0, let me pull up my picture of an array. If my array looks like this, and argv 0 is here, and that was safe to print, and argv1 is here, that was safe to print, it was my name, and argv, what did I do, 100, it's like way over here. I don't know what's over here, and indeed, touching that memory was very bad, like the program crashed. And segmentation fault is an allusion to how computers lay out memory. You've got like a segment of memory here, a segment of memory here, a segment of memory here. Segmentation fault means you touched a chunk of memory that was not yours to use, to change, or to even view. So I got lucky, though. Well, I didn't get lucky. I could sometimes see garbage values. Let me be a little more conservative. Let me put bracket 2, which is just one past what I typed in. It's sometimes undefined behavior. I don't know what I'm going to get. Null. So there's some funky characters there or zeros there. But it's now you're playing with fire, so to speak. These are logical bugs in my program. But it is OK to check if argc is 2, then it's OK to look at 0 and 1, 2 things, and only 2 things. Any questions on that? All right, so where, in what domain is this kind of thing helpful? And there's a couple more examples of argv that you can look at online. Turns out that in the world of cryptography, this stuff really starts to get interesting. So the world of cryptography is all about scrambling information. Maybe back in the day in grade school, you might have passed notes to a friend or a crush that you had in the classroom. And if you were really clever, or your teacher was really adversarial, you might have to like encode your message so that you're not just writing like I love you or whatever, but you instead change all the A's to B's and all the B's to C's, or hopefully something a little more cryptic than that, so that the teacher can't just change all the B's to A's and all the C's to B's. But you kind of scrambled the words. But you scrambled the words, perhaps, in such a way that it's reversible by the recipient, the recipient of your encrypted message. So to encrypt information means to convert it into some other format from what's called plain text to ciphertext, which sounds really cool, and it's just the scrambled version, but it's not random. It's got to follow a pattern, or if you will, an algorithm, so that he or she on the other end can reverse the algorithm and undo it. Now, in the simple example I proposed, like A becomes B, B becomes C, what is the secret that you and your crush know? It's probably just the number 1. Like he or she has to just know if you added 1 to the letters, that they should subtract 1 to the letters. And hopefully they know that if you hit Z, you should probably wrap around to A and not get into weird punctuation or something like that. So you can keep an algorithm as simple as that. So we can think of cryptography really as just an example of problem solving. You want to send a message from someone, yourself to someone else, maybe over a very insecure medium, like passing a note through the room, and you want only one person to know how to access it. That's like providing input, and you want output, your plain text and your ciphertext, so that no one can understand it except you and the recipient. So it turns out that cryptography, there's different forms of it, but perhaps the simplest looks like this. There's 2 inputs, the plain text, the message you want to actually send, and then the key, which might be a number, like 1 or 2 or 25 or 26, and more than that's probably silly because you're just wrapping around the alphabet even more, so to speak. But the output is going to be something called ciphertext. And when your crush receives this message, he or she really just needs to reverse the process. They have to know the key, otherwise they're going to be guessing all day long what your message actually was. But so long as you know the secret in advance, you can do this. Now, of course, there's a gotcha. Like you have to be on speaking terms with this person you're crushing on, because he or she needs to know what the key is in advance. Otherwise, you're just sending them nonsensical values. So that's kind of a catch-22. In order to send a secret message from A to B, A and B need to be able to confer in advance and agree on this secret. But if you need to agree in advance on a secret, why don't you just use that time to send the message directly to the person, right? So there's this disconnect. And we'll come back to this before long, because most of us probably don't know someone who works at like Amazon.com. And yet when I buy something on Amazon, I've been told all these years that it's secure. It's encrypted. My credit card, my name, and all that are somehow encrypted between me and Amazon in Seattle or wherever their servers are. But I don't know anyone there, and yet somehow cryptography still works. So this type of cryptography is just one, called secret key cryptography, but there's public key cryptography and yet other things. And so what you'll find in problem set 2 in particular is you'll have an opportunity to explore this world whereby you'll write software that encrypts and then hopefully decrypts information. And even if you're among those more comfortable, an opportunity to try writing software that takes passwords that are encrypted, or more properly hashed, so to speak, more on that before long, and you try to crack those passwords, actually figure out what the passwords actually were. And it all boils down to, ultimately, in the context of C, taking as input a message, like a plain text, and somehow converting it to ciphertext by manipulating those individual characters, or if you're the recipient, vice versa. And I like to show a clip from, frankly, a film you can watch like literally every hour on the hour around the holidays, A Christmas Story, because that is an example of a very simple form of cryptography. If you ever saw this movie, this is little Ralphie, and he's really excited because over like months or whatever, he saves up and sends in like all of these like cereal box covers or something like that, and gets back finally this secret decoder ring. And the secret decoder ring is kind of a nice mental model to have for the type of cryptography I'm proposing here, this sort of rotation idea, A becomes B, B becomes C. Because if you imagine a ring that has another ring on the outside, you can kind of line up the A's and Z's, so to speak, differently. And that's what he was saving up for. So I thought we'd take just a moment to look at this clip to inspire one of the problems ahead.
Be it known to all and sundry that Ralph Parker is hereby appointed a member of the Little Orphan Annie Secret Circle and is entitled to all the honors and benefits occurring thereto.
Signed, Little Orphan Annie. Countersigned, Pierre Andre, in ink. Honors and benefits already at the age of 9. Come on, let's get on with it. I don't need all that jazz about smugglers and pirates.
Listen tomorrow night for the concluding adventure of the Black Pirate Ship. Now it's time for Annie's secret message for you members of the Secret Circle. Remember, kids, only members of Annie's Secret Circle can decode Annie's secret message. Remember, Annie is depending on you. Set your pins to B2. Here is the message. 12, 11,
I am
2,
in my first
8,
secret meeting.
25, 14, 11, 18, 16.
Oh, Pierre was in great
23,
voice tonight.
12,
I could tell that tonight's
23,
message was really
21,
important.
3, 25. That's a message from Annie herself. Remember, don't tell anyone.
90 seconds later, I'm in the only room in the house where a boy of 9 could sit in privacy and decode. Aha, B. I went to the next. E. The first word is B. S. It was coming easier now. U. 25. That's R.
I'll be right down, Ma! Gee whiz!
T. O. Be sure to. Be sure to what? What was little Orphan Annie trying to say? Be sure to what?
Annie has got to go. Will you please come out?
All right, Ma! I'll be right out!
I was getting closer now. The tension was terrible. What was it? The fate of the planet may hang in the balance.
No, Annie's got to go.
I'll be right out, for crying out loud!
Gee, almost there. My fingers flew. My mind was a steel trap. Every pore vibrated. It was almost clear. Yes, 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 yes.
Be sure to drink your Ovaltine. Ovaltine? A crummy commercial? Son of a bitch.
That's it for CS50. We'll see you next time.